Yo, what's up, everybody? Welcome back. Today we are once again trying to fix a couple. I'm hesitant to use the word bug here. A couple unimplemented features, maybe we'll say, in the Zig compiler that will allow us to run SPIR-V or generate, I guess, SPIR-V kernels that will run on the GPU to generate some geometry so that we can render this SVG GPU accelerated. Right, we're kind of doing all this like SVG stuff by hand, so we've got kind of like a quick and dirty renderer thing that works like okay for this image. It doesn't work for most images, but it works well enough for this one. It's squished because of, just our render resolution. And what we're kind of like doing is we are splitting up our thing into a bunch of like individual contours, right? So we see like each of these like points represents like a segment of a contour. And what we are doing is we are kind of going, for each line, we are kind of looking at how each contour crosses our pixel. And the rule is if we cross bottom to top, that's +1. And if we cross top to bottom, that's -1. If we kind of come inside and back out, that doesn't count for anything. And anytime, if you start at 0 here, anytime the count is non-zero, we consider this like an area to be filled in, and we like memset that to the color of the contour that it's supposed to be, right? It seems to like be working, but when we start to getting it cranking up to like high resolutions, this is like noticeably slow. Like not like slow, but like not like microseconds. Like right, we're in the range of like several milliseconds at like maybe like 1024 by 1024, and if we want to do like multi-sampling anti-aliasing, then that needs to be multiplied by like 4, right? So the time would be like maybe like a whole frame time to render an SVG. Ew, gross. So we're like, we have all this code that does all this work. Let's compile it and run it on the GPU because Zig has like a SPIR-V backend where SPIR-V is kind of like the WebAssembly of GPUs. You can kind of think of it that way. And so we are kind of trying to like one shot do for every line, for every contour, do all of these cross calculations like at once. And as we have started like working towards doing that, we've had to like pull Zig's master branch because the SPIR-V support there is better. And then we're hitting cases that are just like not complete, right? So we're like crashing the compiler in some ways, or emitting invalid SPIR-V code, which will crash the OpenGL compiler at runtime, right? Like so there's like all these things that are not quite there. And yesterday I found a couple more. So if I try to uncomment the code to do like ellipse intersection, I guess, right? So some of the contours in this Blender icon are represented by like a segment of a rotated ellipse, right? So this guy kind of has like something like this. He's got like a radius, a rotation, two radiuses, I guess, like an X radius and a Y radius, a rotation, and then like a definition of where on the contour we actually want to render the line from, right? Or sorry, where on the ellipse the segment of the line is from. And if we uncomment the code to do this part, hold shader Zig. If I just uncomment all of this and then try to build this thing, hold, give him a sec, he's thinking. Boom! Compiler crash. Right? So thing one today is to fix this, and then there's another, I don't remember if it's a compiler crash or a runtime issue, where anytime I use std mem swap, it's also invalid. I think it compiles successfully, but then generates invalid code, I think. So we have to just like fix whatever case is breaking there as well. And I don't know if that's going to take a full stream amount of time, but that's all I have planned for today. So if it ends up being fast, then like fuck me, this is a quick stream. You know what I mean? Because unfortunately, I have to think ahead a little bit. Unfortunately. Are you using the latest Zig? I am using whatever was on master when I pulled last time. Now, I know that there have been changes to the SPIR-V backend since I filed all of my PRs. So it's possible that one of these things have been fixed in the past like few days. However, I do not want to check because if they have been fixed, then we do not have a stream for today. But also it's kind of fun to like look in the weeds ourselves. And then if we come up with a solution and we find that it's been fixed another way, we can kind of like cross-check our answers with that later. If it ends up fast. You sound optimistic. Yeah, my bad. Okay, so let's read whatever the fuck this issue is. I have already narrowed it down off stream to an atan2. I'm pretty sure that that's the cause, but let's just double check that, I guess. So in here, what do? We try to calculate ellipse angles for y. So I guess, what is this doing? He's saying for a given scan line, I think what this function is trying to do is he's saying we have a rotated ellipse, right? And we have some scan line going through this. What angle is this? And what angle is this? Probably something like that, right? Maybe the other way. We're trying to like resolve these 2 points in some way. So let's just see, we'll just like kind of bisect a little bit. Bisect a little bit. The compile times are really slow because I've compiled the Zig compiler itself in debug mode. So yeah, there's something there. Yeah, I believe that I found that it was in this function. If I just like comment this out and then say return null, I believe this compiles okay. Yeah, it does, right? So it's something to do with this atan2 call. Let's take a quick look before we start digging into the guts of atan2. Let's see if we can find like an approximate area where he is mad. Right? So we've seen this panic before. OpenGL does not have how do I say this? He does not have like a C ABI to conform to, right? It's not like we have like a C library that we're linking to and trying to like use ints, right? So the direction that I have been given by the people who've been reviewing my PRs is that OpenGL should not implement this idea of a C-type bit size, right? So like the fact that somebody's coming in and saying like, try to get the bit size of long is like a bug, right? That should never happen on this platform because like a C long shouldn't exist on this platform because there is no C interop, right? So the question then becomes is like, why are we generating this? I think somewhere in here, it shows us exactly why that is happening, right? Somebody is emitting a bit size of C long type. And so I guess the question is, why is it emitting this, right? We know it's somewhere in atan2, right? But we don't know why. So we're looking for something that's like maybe doing a bit cast of a long, something like that. Can I pet that dog? She would love it, but unfortunately you are not here. So, well, probably fortunately for me, to be honest. So I guess we're trying to look for anything in here that is doing some form of bitcast. Is NAND maybe? No. Bitcast here from an F32 to a U32. So we are seeing a bitcast here, but I would imagine that, hold on, I need to ban someone. I would imagine that this is okay. It might not be, but I would imagine that it's fine. Scrolling down, there's a bunch of just like them doing some like bit hacking, you know, representing the float as a U32 and doing some tricks in there. And then we get down to atan, which is not atan2. We are probably on the 32-bit path. However, is it clear that we are only compiling the 32-bit path, the floating point 32 path? Right, we do see some stuff that looks kind of like they are seeing bools and ints with do not optimize away. That's kind of interesting. So that could be in here. If this like comp time unreachable, no, comp time unreachable seems like that means that it wouldn't even make it there. That would be my guess. Hold on, let's look again. Like, does this stuff that's being generated look like unreachables? No, right? There's like definitely like code in the array case, and code in the pointer case, and code in the float case, right? So there's something there. So it doesn't feel like it's this area. So let's kind of like dive a little deeper into the floating point 32 version. Good day. I learned about the plan to replace C types from Zig with a new built-in, right? Something like at C type from reading one of your PRs. Yeah, that's what it sounded like to me. That's what he said, and that's what I believe. Okay. So in here, do we see anything that resembles a long bitcast? No, right? I don't see anything that resembles the thing we're looking for. So I guess we have two avenues here. We could try to scope. We could try to like, how do I say this? Fuck. How do I say this? We can try to like reduce the problem, I guess, right? So like one thing we can try is bit casting a float to a U32, right? And just see, does this actually trigger the thing? Like, I don't think it should, but maybe. Yeah, that's fine, right? What about if we skip atan2 and just do atan with no 2, right? That'll at least help us bisect in some way. Const x is stood math atan. And then let's do this. And then this is like make it so it compiles. Okay, good news. There was a bitcast in there in 32. Yeah, but to a U32, but not to a long. Not to something that resembled a C type. At least as far as I could tell. Maybe I missed it. Okay, so then do we have access to atan binary 32? No, but what if we just copy this, paste this thing out? Right? Let's just kind of we're just reducing the problem, you know? What about that? I guess math here needs to be imported as stood math. And mem needs to be imported as stood mem for these to compile. Okay, so that's interesting. We are still getting this. We are still getting this. So I would maybe we can like reduce this problem like heavy with wherever the fuck this was. Let's just pull this all up to main to kind of like reduce the amount of stuff that is being compiled at all. You know? So where was this? It was called arc. What is it? Tan binary 32. Here we go. Okay, let's pull this all the way up to the main of the shader. And then comment out like pretty much entire. Let's like make a new main actually. Maybe is the way to do this. And then this guy is going to pull some value at runtime to make sure everything is getting compiled. I don't think that actually is something we have to worry about too much, but you know, you might as well. And then can we call atan binary 32 float from int val. And then let's see if this still freaks the fuck out. Cool, it does. Okay. So I guess now we just start commenting stuff out of here, right? Right? Like, surely. Or maybe we get a little bit more intentional about this. Like, this feels like the bug, right? Like, this is the only bitcast that's happening that I can tell. Unless do not optimize away is doing something. Oh! Here we go. I assumed that this was just like an ASM statement of some form. Oh, yeah, here we go. Here we go. This is where the bug is. Oh, easy. So like, what the hell is happening here? Do not optimize away. This looks like so x86. Does it not? Maybe it isn't. Maybe the ASM syntax is the same for all platforms. And so by putting an empty ASM block, you've like managed to tell the compiler that this is okay. Is this all still about rendering FCGs? Yes. Yes, it is. Interesting. It looks like a memory barrier. Yeah, but I was just like, the memory barrier looks so... Like, in my head, it looks like what I would do on my desktop platform, but that's not necessarily true, right? Because it depends on what this syntax means, right? What is, like, why are they... What is this for? You know what I mean? Oh, I guess maybe the parameter type given to the ASM block needs to match this value in some way. But like, yeah, what the hell is going on here? So if bits is less than max GP register bits, which like I don't even know what that means. Max GP. What do you think GP stands for? Not sure. But it sounds to me like they're saying like, what is the biggest thing that I can put in a register? Right? That's what it sounds like to me. General purpose? Oh yeah, good eye. That does sound right to me. Right, so they're kind of saying like a long represents the biggest thing that you can put in a register. Simple. Right? We could maybe fix the bug here by specifying something here, but like we'll think about it more later. Let's understand what they're doing and then come up with a solution after. So stage 2 backend looks like, or whatever this Zig compiler backend is, doesn't support this. I believe this is like as they're compiling, they're like bringing in more and more features. So all of these things are guarding the stage 2 backend. Makes sense. So for arrays, they are looking at every single element in the array. Makes sense if that is less than 64 elements long. Otherwise, they do not optimize away the pointer that this thing is. Sure. What are they doing if it's a pointer? Do not optimize away C. Oh, if this is stage 2C, but we're going to be in this case. Right. So if the thing is a pointer, you can say, reference this memory location. What? I need to look up what these like tags mean. Does the Zig language reference give us this? So like for those of you who have like not seen this trick before, by the way, they are basically saying by making an assembly block, they're kind of saying like, hey compiler, you don't know, you can't like trace what is happening to these variables anymore, right? So by passing in like val2 into this block and then specifying that we are going to read from this thing, even though there's nothing in the assembly block, the compiler, because of this, needs to like says, oh, okay, I have to keep this value because I don't know what they're going to do with it, right? That's like what the general trick is. I don't know what these tags all mean though. So can we look at the language reference and look for like the ASM block definition? This looks... Okay, here we go. Assembly. For some use cases, it may be necessary to directly control the machine code, blah, blah, blah. For these cases, when used inline assembly, here's an example. And what are they have docs everywhere. Okay, so there is stuff in square brackets, which is the output, it looks like. It is possible in the future, Zig will support multiple outputs depending on how this is resolved. It is allowed for there to be no outputs, in which case the colon would be directly followed by the colon for the inputs. Okay, this specifies the name to be used in %ret syntax in the above assembly string. This example does not use it, but the syntax is mandatory. Oh, I see. So there's 1: for output, 1: for input. Our output is null, but our input is not null. Okay. So then we're down here. Next is a list of inputs. The constraint for these inputs means when the assembly code is executed, Rax shall have the value of number. So that's this and this, right? When the assembly code is executed, Rax shall have the number, and RDA I shall have the value of arg1. Any number of input parameters allowed, including none. And then I assume that these are like syntax sugar for you to be able to like reference these things by their nice names in the assembly block. Next is the list of clobberas. So this tells us what things in the output will be changed by this without it necessarily being the output. Okay, that makes sense. So here, this doesn't tell us like what the quote strings mean though. I assume that these are related to some form of like LLVM naming scheme or something. Pebble, thank you for the raid. What's up, guys? Yeah, okay. We are trying to understand what this do not optimize wave function is trying to do in the Zig standard library because it does not work properly on SPIR-V platform, and we want to know what we're supposed to do to fix it. Okay. So, question becomes, like, I assume this is like auto allocate register. Um, Someday Zig will have its own assembler. The documentation section will be updated before this. Okay. So we don't. Oh, here we go. Output constraints and input constraints. So this is an input constraint, and this is documented. This. Okay. Input constraints. For example, constraint string of equals R0 says to assign a register for output and use that register as an input as well, beginning with the 0th constraint. With double checking, this is input constraints, right? Constraint string. Yes. Cool. This looks to me, yeah, look at this. This is exactly the type of thing we're seeing here. Equals quote R source. So where do they define in these GCC docs constraints? I guess we're looking at, this is output operands. We're looking for input, right? I guess. Here we go. Constraint. See constraints for ASM operands and for details. Perfect. Simple constraints, probably. Okay, M means memory operand is allowed. So for some reason, for floats, they are using memory constraint. That's confusing to me, right? I would have thought that this would just be like a raw register load. I assume R means register, right? A register operand is allowed provided that it is in a general register. I guess maybe for some reason you don't know if this thing's already in a register or not, or something. Not entirely sure. So this makes sense, right? They're saying load this bad boy into a register, but you can only do that if it fits in a register, right? That's what it makes it. x87 didn't have easily accessible registers, so M makes sense for it. x87. What does x87 mean? Is that like floating point bullshit? x87 CPU. I assume that that's a floating point related subset. I see. So you're saying that you can't just like look at these registers necessarily. You have to, well, I don't understand, but I believe you. I do believe you. So you're kind of saying like, in order to access this value, it has to be in memory somewhere for you to like put it in this floating point operation space or something. And so like the compiler might know that, so you have to say memory. Interesting. Okay, cool. So we've got some clues here, right? One is that this is only used in the integer path, right? Because this guy's basically asking, do we fit in a register? So like, even if this worked, like, how do I say this? Even if this worked, would we be able to use it? Like, do ASM blocks work in SPIR-V, or are we like totally fucked there? You know what I mean? Like, can I, like, if we just do this trick, right? Like, is this legal? Surely not, right? Right? Like, hello? Why is this happening? Why is render util even being compiled? What the fuck is happening? Oh, because of all this stuff? I see. Okay. So weirdly that does compile. That's interesting. That's interesting, because I would have expected it not to. Can we just run this command directly? My bad. Okay, so there is like an assembly instruction generated. It is valid SPIR-V though, because it sounds insane to have async SPIR-V. That's kind of what I'm saying. Is like, this seems weird to me. So like, what does the SPIR-V backend even do there? When it sees, what's the thing called? Assembly? When they see an assembly thing, what do they do? They're letting you go crazy. It looks like a real implementation. That's crazy. Ass. Sorry, I can't I can't help myself. Yeah, interesting. What are they doing? So they are looking, I mean, they have an instruction set in here and they're letting, cool. That's kind of crazy. They kind of let you just go crazy. They kind of just let you go mad with it. That's sick. Okay, so like theoretically, this idea should work then, right? I think. Oh yeah, I don't see any reason why this trick wouldn't work on SPIR-V. I mean, my context is extremely limited, but like from the perspective of like the generic Zig semantic analysis doesn't know how to like inspect into the assembly block, so it has to keep the stuff around. Like that seems sane. It seems sane. Okay. So then all we have to do is figure what the rules are for the SPIR-V backend in terms of what the biggest register size is, or like what registers you're even allowed. It might be anything, right? Because like the SPIR-V thing is like, you don't even have registers, right? You have like Stigl static assignment is what they call it, right? If I, hold on, we need to pull in SPIR-V tools, I believe it was called. So I can show you what the fuck I'm talking about. Give it a sec. So SPIR-V dis. Right, so like this thing, we don't have like registers, right? We don't have like load this value into register X. What we have is, hey, I'm gonna load this thing and I'm going to put the %23. That assembly implementation was for OpenCL and Vulkan OS backend only. Oh, I missed that. AIR assembly. I don't see any. Where did you see the Vulkan piece there? Because this is not Vulkan specific. Oh, here there is this. No, but that's not even in this part. I don't. Where did you see it saying only Vulkan? I don't see that anywhere. I do not see anything limiting this to Vulkan and OpenCL. Unless it's like down the call path somewhere. But I'm not seeing it, and also we're not crashing, so. I mean, we could also like prove this, right? If we just go into our thing and we're like, I don't know, OP store. It was switch. I think that I had it, like, if I searched for Vulkan OpenGL, this was like in a completely different code block, right? That's like not even like, and I don't think that it's in that function, right? I didn't see it in that function, but maybe. I don't really know what I would prove this with. I was gonna say we could like put some commands in here and then see if they go into the final executable, but I actually don't know how to do that. You know what I mean? Like, that's not valid, but maybe it'll compile anyways. I wonder. It's saying failed to assemble, But I think just because I put invalid data in there. Failed to assemble. Yeah, they just have assemble, assemble, fail. Yeah, I'm not seeing it. I think it's fine. I think it's fine. Anyways, I don't know how to like put a proper like a sane assembly instruction there. I guess we could look at the disassembly and then just like copy one of them. Like we can maybe just put an OP label. Although I don't really know like what that does. Maybe OP return. Just to, like really fuck shit up. Return must appear in a block. Oh, they're too smart for me. They're too smart for me. Okay, I give up. I give up. I give up. But I think the idea here still works. So what I was trying to say a second ago was that like all of the SPIR-V execution model is single static assignment. So the idea is that like we have 400 GPUs that this thing could run on, right? And every GPU manufacturer wants to squeeze the juice out of their GPUs so that it looks better for them. Everything runs better. OP no op? Did you make that up, or is that like a real thing? Let's see. You tricked me. Maybe. I don't know. Maybe that is valid, but it doesn't work. I made that up. Fuck. I should never listen. No listening. Fuck. So, like, the GPU manufacturers all want their thing to be, like, uber fast, which means, like, they want to be in control of their register allocation and, like, what things are pointers and all of that stuff, right? Like, their sauce of how they go from this, like, abstract language to GPU-specific code that can be executed is, like, part of their secret sauce, right? So, it makes sense that we don't have registers at this level. But the question is I guess my gut says that you could give it anything, right? Because probably like the thing that is being fed into the SPIR-V assembler is the like ID of this value, right? Like it's gonna be like, hey, this value has %21 or something, and we want to feed that to the next statement. So that'd be my guess, which means that it could take anything. Right, it doesn't seem like there's a restriction there. But is there some way to double check that, I guess is the question. So I guess it would be nice to look again at the AIR dump. Right, so this thing says assembly void volatile. The third parameter is, the second parameter, 0, 1, 2. Sorry, I guess third index 2 would be the information that we are interested in looking at, right? So how do they extract that? Outputs len, inputs, right? Unwrapped ASM, surely it's going to be inputs. Which I guess maybe is making it farther down. Iterate inputs here, right? So for each input, they are looking at the type of the input. Ignore the constraint for now. Use T constraint to supply types. Oh, interesting. Otherwise, C for constant. Otherwise... Wait, am I high? Does this thing only support constants and types? I guess maybe all inputs are constants. I guess they kind of are. Right? That seems reasonable. OP NOP, not OP NUOP. I did look this up. Okay, you know what? Since you went through the work, it does look like that. No, that is not compiling. Why? Am I crazy? Where is the part where it gets mad at me? Or, hold on, did I just have verbose AR on here? I did. So it just looked like... yeah, wait, that's fine. Nice. Good eye, good eye, good eye. So it does look like that assembles, and then we can, like, SPIR-V dis the thing and look for OP nop. Hell yeah. Hell yeah. So we do have some proof. We have some proof. That's nice. Yeah, it could be that you are only allowed to have constants, right? Because in this execution model, you can't, like, create variable 1 and then modify it. That's, like, not a thing you can do. But then how come this compiles with the R constraint? That's confusing, right? I would think that that shouldn't work. You know what I mean? I would think that shouldn't work because we only see C and T here. I actually have else. Oh no, sorry, I misread this. Otherwise, if it's a type, fuck off. But we can put this thing in the value map, and so they resolve the operand as an ID that they pass in. Yeah. Okay, so this is exactly what I thought. This is exactly what I thought. Where just this turns into some static assignment ID. So I don't see any reason why this wouldn't work. I don't see any reason why this won't work. Which means, to me, it seems like we could maybe special case the SPIR-V variant and just say, like, on SPIR-V, like, it can be literally you just, like, fucking rip an R. You know what I mean? That sounds like I was saying that we should say a slur. That's not really what I meant. I meant we can just rip this without any checks. That's kind of how it seems to me. That's how it seems. Also, I realized that we were looking at the wrong version of Do Not Optimize Away. We should be looking at the one that we have here, but it's probably the same. Yeah. So my gut says that we should do something like if, like, platform is equal to SPIR-V, right? However the fuck we get that information. Do we have built-in? We do. So we should be able to be like, if built-in target is SPIR-V, arch CPU is ABI hold OS CPU ABI O format. I mean, it's gotta be CPU, right? I'm pretty sure it's like this. He thinks that doesn't exist. That's funny. Target zig is SPIR-V. That happens on the arch. I just saw it there. My bad. It's CPU.arch is SPIR-V. So if this is true, return after doing just like the stupidest version of this. And we'll say, SPIR-V doesn't have registers per se. How the fuck do you say per se? Per se. Do you guys hear that, or is that just for me? That's just for me. Hold on. You guys don't get to miss out on this beautiful per se. You know what I mean? You guys gotta...
Per se.
Did you guys like that deafening noise that you just got from her? Get fucked. Also, I couldn't hear that there, which is crazy. So can I fix that? The, like, stream audio, if I, like, put something to recorded audio, this has to make it to my ears somehow. It's gotta be, like, here, right? It's gotta be here. Hold. This does not matter at all, but...
Per se.
Ow! Holy, yeah, okay. Okay, anyways, I heard it that time. Per se. What does this mean? Like, is this... etymology, which I think has like a P in there. No, it doesn't. I thought it did. Latin phrase meaning by itself. Sure, this doesn't have registers per se. That doesn't mean what it means to me. As one would expect. This is what I would expect. This is what I would per se. Fuck. Okay, sorry. I gotta shut the fuck up. What are you trying to use do not optimize way for? Well, it's just like in the code path of atan2. You know, it's just like in there. So we need it to not crash the compiler. SPIR-V doesn't have registers per se. It just has SSA IDs that I believe any value that we get here should coerce into the same, you know, ID type, and make it into the assembly block. No need to do any fancy checks. I guess theoretically, maybe I've changed my mind, right? Because like when you see a pointer here, they're like, hey, you should like do not optimize away the thing that is pointed to, which is interesting. Right, so maybe these same checks are required. I've changed my mind, right? Because just because the pointer makes it into this ASM block does not mean that the compiler could not be smart enough to remove references to the data that the pointer is pointing to because it knows that you're not accessing the data because you didn't give it the memory constraint. So I've changed my mind. Instead, what if we did something like something like this? Like, because this is really the only major problem here. Everything else should just work. If is SPIR-V, like, just pick like an absurdly large number. You know what I mean? Like, just for now, as like a little cheat, a little hack. A little cheat, little hack. Let's just see if that fixes the problem. I guess we need to get this change into us, we need to recompile this thing. No such function. That's interesting. It's on Arch. What do you mean, no such? Maybe the built-in variant doesn't have it? The fuck? Oh, is the V capitalized? It is. Classic. Classic. You can specify a flag to point the compiler to the location of sydlib so you don't have to compile. That's a good point. That's a good point. But what you gonna do? I've already done this. Can you move it into inside the int case? Yeah, but I think that I don't need to, because like the int case is still gonna get hit sometimes. You know what I mean? You know what I mean? So we might as well just fix it the way it is. But I believe you could. I think you're right. Why? I don't understand why sometimes it decides it has to like do a full recompile of like the world, and sometimes it doesn't do that. I do not understand. But that's okay. I don't need to understand. Although it would be nice to so that we can make this thing go faster. But you will reduce the visibility of this variable. I agree. But, how do I say this? Like, especially in this context, where this is like not a code base that I feel strong ownership of, right? To me, the idea of minimal diffs makes more sense, right? Like you can imagine looking at this code, by the way, that this max register bits thing used to be in the float case, and now it's not. I saw on the another version of this that there was like a comment about a bug or something. So you could like imagine a world where like this thing does want to be used in here later. So it's just like, how to say this? Making changes unrelated to the thing I'm trying to fix is not like my prerogative. You know what I mean? It's for when I'm in a code base like this, I am just trying to do the minimal change that correctly fixes the bug. Where if this was something that I felt stronger ownership of, maybe I would make that change because I'm like, oh, I know that's okay, and like it does reduce the scope, and I prefer that a little bit. But even then, I think that like changes need to be justified, right? Because otherwise, you just end up with a bunch of people that are making changes that they like for stylistic reasons, right? And those, you could end up with two people in a code base like trading options back and forth, right? They're like, every time this guy sees it, he puts it in one way, and every time this guy sees it, he puts it another way, right? So like every change needs to be justified to the point where it's worth making, right? The first time you write something, you like kind of have all of the freedom in the world to do whatever the fuck you feel like is just like naturally best. But like once it's in there, now like every change has a cost in some way, right? And so to me, the idea of like taking this and putting it down here is like probably not worth it, right? Where to some people, you know, it's just not worth the diff. That's kind of how I feel. That's kind of how I feel generally. This window. So let's bring back atan binary 32, I guess, and run our build. Who, now that the compiler has been built again, he's like, I'm compiling this thing. I don't really know what maker is, but it's his first time set up. Give it a sec. Boy's thinking. You're right, I should have just pointed at a different stdlib. You were right. I should have just done that. But I've committed. Now that we've felt the pain, next time I probably will just change the stdlib path. You've convinced me. Because this sucks. Maker is your mom. Thank you. Thank you. Ooh. There we go. Okay. So that's interesting. So this thing compiled now. We did fix the compiler crash. However, we are now getting some invalid code emitted, which is fun. So let's look at what that is. Invalid code emitted, right? So let's just double check that this actually causes like a concrete problem for us. So if we come back to trying to run everything as it was, fuck our copy pasted version of atan binary 2, and then we also have to fix our render util, I believe. I think we had some commented out code in here. That needs to go back to however it was supposed to be. So I believe that if I understand this correctly, that we should end up with a runtime crash because of the fact that this doesn't validate correctly. So if I try to like run this thing now, I believe, oh, we don't. Oh, probably because I didn't actually fix this thing. Why not? Oh, maybe we're good. Hold on. Oh my god. Var here. Wait, maybe we're good. Except that the arc pieces are not there because we probably had to recompile this guy as well. I forgot. Aha, here we go. Right, so this is what I was talking about where I suspect a runtime crash of this thing because of that error. So what is this saying? instruction may not return a logical pointer. So can we go back to... Sorry, I know I just did all this work to say let's not do this, but let's go back to kind of doing our atan binary 2 thing right here. Can I just hold undo? It's probably easier. Okay, so why is this happening? SPIR-V dis. Zig out bin shader SPV. So we're looking for like %789. 789. There we go. So what is this guy trying to do? Well, what is the error actually? Let's read the error again, because I actually need to know what that means. Zig out bin this guy. Instruction may not return a logical pointer. What the fuck does that mean? What the fuck does that mean? So here we're trying to say we have some structure and we are trying to pull out the first field of it. I believe is what this is trying to do. I believe. Remaker. They now made it so that build_zig is a script is compiled separately from build system. It now writes generated options to a bin file, and maker reads them and actually compiles your program. So it's supposed to be faster compile after making build_zig changes or something is the claim. I see. Yeah, so I believe OP composite extract is take a field from a struct out. Extract a part of a composite type. Yeah. Okay. So then he's saying, like, this may not return a logical pointer, which is interesting. This is a pointer to a floating point 32, is what this is saying, I believe. Because the function is the storage scope. So this is like pointer F32. We can double check that. Hold here. Yeah, so here they're saying, give me a pointer in function scope, which is just like normal SPIR-V execution scope, floating point 32, where F32 is a float type of 32 bits. Yeah. So they're trying to say, hey, I want to extract this thing from 784. So theoretically, 784 should be of type function of this type. And he's saying, give me the first thing. And then he is saying that may not return a logical pointer, which is interesting. Maybe because this thing is not a composite. Maybe this is not a composite type. So this thing doesn't give us a pointer. Would be my guess, right? Maybe in this context, we are supposed to just give the value back itself. Because probably 789 wants to be that thing, right? Because here, they are then saying access this thing as a pointer F32, right? They're trying to get, so this is going to 790, and then they are loading 790 with, yeah, so they're expecting here, they're calling OP load, which must take a pointer to a floating point. They're loading with that pointer they're trying to get the value of that thing in 792. So this thing is surely supposed to be a pointer to F32. Surely. What is 784? Oh, yeah, that's a good point. That's a pretty good point. That 784 is struct 97. That's a good point. What is struct 97? So, yeah, I see. So I misunderstood this. This is probably the return type, right? This is the return type. So they're saying, given 784, which is this structure, I want the first field, which is supposed to be a floating point 32. Good call. So what is this? This is a structure with a pointer to a floating point 32 and a U32. Okay. So that seems kind of reasonable, right? But this guy is saying this may not return a logical pointer. Can we look at the source code for this thing and see like what he's checking here? I want to know what the fuck this thing is doing. Or is it trying to say instructions in general are not allowed to return pointers in the OpenGL dialect? That's very possible. Very possible. Very possible. I wonder if it knows that this is OpenGL dialect. I don't know if that information is like in this thing. You know what I mean? Like he has the SPIR-V version, generator version. I don't know if he knows that it's OpenGL. I don't know if he should know even. Was this CD SPIR-V tools? And then what's the string I'm looking for? Instruction may not return. Okay. Validate logical pointer returns. This is a lot of words. It does kind of seem like it's saying that there might not be a pointer. Right? Like, just kind of skimming what this thing is saying. He's like, if we have the capability of variable pointers storage buffer, or we have the variable capability of variable pointers and this thing is in work group. And so yeah, if we have variable pointer storage buffer and this thing is in the storage buffer storage class, or we have variable pointers and this thing is in the work group storage class, then we're fucking chill. Then this, oh sorry, this is a different case. So oops, fuck. I just was it instruction may not return a logical pointer. So I'm sorry, these are all of the instructions that that it knows how to validate. And then we're using composite extract, and maybe he doesn't know. Maybe like composite extract is not allowed to do that or something. You know what I mean? It does seem kind of like that. Would it be possible to omit SPIR-V's TAN instructions and bypass this? Maybe, but I'm kind of curious what the bug is. You know what I mean? Because whatever the bug is like not correct. Could it be similar to this? Yeah. This is probably the same bug. Well, it was closed last month though. But it does seem kind of the same, right? It does seem kind of the same. Oh, but this is just like in a specific path. But sure, I do think it's like the same problem. So my gut here says that we are not allowed to store this thing in memory. Like, it's something like a pointer to this thing in function storage class, like, does not necessarily exist. And we have like tried to put that in a structure and then pull it back out. And he's like, yo, dog, like, we're not allowed to do that. Maybe. Okay. I wonder if we're allowed to do like pointer access chain though. What is the rules in these cases? So in all of like the real cases, we can only return a logical pointer in the storage buffer or workgroup storage classes with appropriate variable pointers capability. Yeah, it sounds like no matter what, this isn't valid. Right? That's kind of what it sounds like. So the question then becomes is why is this code being generated? Right? That's the next question. So this is in 789. We are within the function. What function are we in? We are in atan binary 32. Okay, can we look at the implementation of atan binary 32 again? Is there some sort of like reference to variable taken that he then is trying to use later. I would guess maybe this stuff, right? Like the representation of him trying to pull out a pointer as the first field sounds a lot like a slice, right? Like pointer plus len. And we know already that we are not allowed to generate slices in SPIR-V because it doesn't know how to access them correctly. I bet you if we gave these things the size types, this bug goes away. So this is 5, or maybe we just say like this. I bet you if we do this, it goes away. Which means that the change that we made to ban slices was not sufficient on this, like, by the way. What is he mad about now? Is that not fine? Oh, he can't infer array size. Oh, sorry. It has to be like this. Yeah, like this. Okay, here we go. I bet you this is it. Let's fucking go. Let's fucking go, baby. So yeah, the bug, just to be clear, was that by assigning these values, whatever the fuck they are, right, as slices, the compiler has probably generated, if we look at like the AIR generated, the analyze assembly, right? If we look at the top of this function, he's probably creating slices in some way, of course. And those slices then are doing like pointer arithmetic that is not valid because that pointer arithmetic, like there are no pointers to things in block scope in SPIR-V. That's just like not a thing that exists because you don't want the SPIR-V like backend compilers that are the GPUs drivers are making. You want to like make the problem easy for them, and so just banning pointers makes it a lot easier for them. I believe. I mean, I've made that up, but that would be my guess. And I would guess that somewhere in here we're looking for like some sort of like, you know, like pointer cast here, right? These pointer casts are saying, give me a pointer to a pointer F32, and that's then we are not banning that correctly. And then we are trying to use them, and he's trying to use them as if they were in the correct storage scope. So there's like a couple bugs here that are stacking, right? One bug is that semantic analysis should ban this, and the like codegen should check the constraint correctly, right? Like both of these guys are failing. So I think the fix here is we try to figure out what pointer cast is happening. Right, so we do see a pointer cast to pointer 32s of hold. Can we maybe you know, out.text pointer cast. So is this the one? atan binary 32. Well, actually, let's like we can just reduce this problem, right? We don't need to use this version of the thing. We can just be like const x is a const f32 is equal to 1, 2, 3, right? And then we can just try to index into this thing. And this should be equivalently stupid. Huh. Why does... That's interesting that we are not failing here anymore. That's interesting. I would expect this to output the same bug. Does the underscore syntax mean array of comp time to do size? Yes, it does. Interesting. Do I have to use this thing in some way? Function test some function let's take val in or u32 or something, u size maybe. And if we put this in here and then call this, does that like change anything? No. Can we look at the SPIR-V disassembly of, or maybe like the verbose AIR of this thing? No pointer cast anymore. That's interesting. Interesting. Maybe it needs like a runtime value into this array, right? Like maybe it's something to do with the fact. Oh no, we are using a runtime value into the array. What the fuck? Are these things getting like re-sliced later? No. Interesting. Very interesting. Are we getting the index, or is it like, is it being too clever and like compiling something out? Yeah, maybe he's like getting a little clever. Can we prevent this thing? I guess we can do our little do not optimize away. Wait, hold on. We're geniuses. We're geniuses? We're geniuses? Um Okay, interesting. So he is looking at the argument that came into the function, using that to index this slice, and that seems to be generating valid code. So why in the other version of this thing is he generating like pointers? Am I missing somewhere where he is somehow like, I mean, I guess what we should do is we can just start commenting things out, right? Maybe that's the play. We go back to calling this thing and we just like start just like I don't know, like hold. I guess we almost certainly, oh, I guess we'll see. Yeah, so that's fine. Uncomment this block. Uh, hold. Hold. Okay. Do you work with Zig in your day job? This is my day job. So, yes, but also no. Because my day job kind of doesn't exist. So it's gotta be in here, right? It's gotta be. I didn't know, yeah. I mean, that's fair. It's kind of crazy that I don't have one. I'll say it. You know what I mean? Like, I'll fucking say it. But, you know, I'll take it. Kind of nice for me. Oh, yeah. I mean, this is the only place A10 low and A10 high are used, right? So, yeah, it is this. So the question is why? Why is this so different? It's great that you can make a living piece here. Well, yeah, I don't really understand it because the streaming definitely doesn't cover my costs. But I guess, like, the index funds have been going crazy for the past few years, so I haven't like run out of money yet. So it's kind of sick. Eventually, we will have to get a job, but for now, we're safe. For now. Yeah, I wonder what makes this so different. I wonder what makes this so different. Like, if I just delete everything in between here and like assign ID to be something myself, like if I just simplify this, like what happens? Like, because this is the thing that was causing problems, right? So if we're just like const ID is equal to 4, like what happens? You know what I mean? What do you mean undeclared identifier? It's right here. Hello? Oh, I didn't save. That would do it. S1, S2? Hell, whatever you want to say. I'm like mid-30s. Early 30s, one of the two. One of the two? Okay, we're getting closer. X unused. We'll use it there. ID. I guess ID known at compile time is a little bit bad. But yeah, okay. So ID is I don't know, X int from float X or something. I don't know, let's just see. Like, okay. So this is still causing problems. Interesting. Now what if we just do like atan low ID? What if we do that? And then comment this is equal to atan high. He's not used anymore. Okay, that's still causing the problem. Am I crazy? What the fuck is the difference between that and what we were trying to do before? Okay, we'll just reduce the problem even further. Smaller. Ditch the sign thing. Was it just because I wasn't returning something? Like, was it just because I, like, did this? Ah, I see. And this thing wasn't smart enough, I guess. Oh no, that is. Okay. I did 1, 2, 3 in here before. I wonder if that changed anything. The fuck? Maybe I had like this as a U32 in here already? Maybe it was too smart for that? No? I feel like we fucking did this function already. I'm gonna say it, I feel like we did this one. But I guess, you know what? When we do it this way, it's... okay, fine. Fine. Okay. So now we should be back to... Yep, there we go. Now it's much clearer, right? This is definitely a pointer cast. Definitely a pointer cast. So I guess the first thing to do is just check our constraints on that pointer cast, right? I think that's fair. So we're looking for somebody who emits like pointer cast. Add typeout, make pointer const. Let's see. What about in this function? Array concatenation. I don't think that's it. Could be just from a pointer cast at the lower level. However, I would guess not. Can I dump the ZIR that comes out of this thing too? Is that a thing I can do? Verbose intern pool, maybe? I don't know if this is what I want. I don't think it is. Oh, oops. Wrong place. This looks very much... it could be. Does, like, pointer nav sound like something? I don't really know where intern pool sits in this whole compiler chain. Where does Zer pointer cast come from? That's the question. So this is looking at tags from instructions, which is a bunch of instructions from ZIR. Okay. Is there really no way to dump this shit? I was wondering earlier if the problem might have been using C long somewhere. I forget where. That was uh a while ago. That was like the first level of the bug. And that was a problem. I think we fixed that by fixing std_mem do not optimize away. But now it looks like I'm pretty sure the problem is just that they're taking it's this like pointer. It's the fact that this is a pointer, right? We proved already that if we change this to an array that it works. So then I'm trying to just make a compiler error that catches this for us. Ideally, you could convert this to an array when you know that that's how it's going to be used, but like we're too stupid for that. Interning usually means collecting and deduping literals, I think. That makes sense. So what do we have on build.exe again? Display linker, display Z, debugging for this, C imports, LLVM. Yeah, maybe it just doesn't exist. Maybe it doesn't exist. Well, there's also like ast_gen. I feel like I've seen. Hold. Oh, dump ZIR. But what am I supposed to, how am I supposed to do that? There's also AST check, which maybe outputs ZIR? Nah. Dump a file containing cached ZIR. Compute mappings from old ZIR to new ZIR. But how do I like make ZIR? Hold. Build obj, maybe. ZIR. ZIR does not show up anywhere in here. Is it not really not possible? Maybe it is, and I'm just too stupid to find it. But okay, let's just go this way then. Found a pointer cast. I don't think that this is going to trigger. I find this hard to believe. You know what I mean? I just find that hard to believe. Because it seems like it's more like an assignment of some form that I would think is going through some other path. Ooh. This is a comparison of some form. Field parent pointer. Nah. Where is this? Field parent pointer. Nah. Field parent pointer again. It feels like this is the only cases of this. Yeah, okay. What was it? Pointer cast. This is what we're looking for. Built-in extern. Doesn't sound like that. Safety check sentinel mismatch. Nah. Field pointer. No. LM pointer one layer only. It doesn't sound like it to me. LM pointer vector doesn't sound like it to me. Coerce? Coerce sounds like the right spot. Right? We are probably coercing one thing into another by assigning it. Kamuna, thank you for the prime. Much appreciated. Yeah, I bet you it's here. Oopsies. Was it coerce extra? Pointer cast time. Because we can also check if it followed immediately by a load, right? Because that would be a good clue. Ooh, it is not. So maybe not here. Maybe it's like directly after a store safe, though. That's interesting. Okay, I'm less convinced. Oh, but it could be this. Could be this. Yeah, that seems likely to me. Unless there's like another one in here, but Let's like rip it and just see what happens. We'll just see what happens. Ugh. I'm glad earlier when I was like, maybe this will be a short stream. I'm glad that I was wrong. Can we get rid of this, like, verbose AIR for a second? Not so lucky, huh? Alright, we keep looking. Add tie up pointer cast. Coerce compatible pointers? That sounds promising. They are compatible pointers. Compat pointers. This is one of those worlds where it's like, dude, if we were just like good at debuggers, which is hard to do in this language the way the debug backend is set up right now, like what you would really do is you would set a breakpoint on add tie-op and then look for a pointer cast and then log back traces of all of those places, and then maybe you could even check if like you could like in your debugger make like a little check. In fact, we could do this here, right? I guess like theoretically we could look for if tag is equal to pointer cast, right? And like something, then we could like emit a crash so that we get the backtrace, right? We would just need to like figure out the destination type and the instruction, but I don't maybe I'm just too stupid to figure that out, but there's probably something that we can do there to figure out that we're casting. I guess we only have the one pointer cast. Yeah, so we can't just say like if tag is equal to pointer cast, then we can crash, right? Because there's only one place where this is happening. We should have just done this from the start instead of just fucking randomly putting logs everywhere. Fucking idiot. Fucking stupid idiot. What the fuck are we doing? What the fuck are we doing? This is a way more effective way of doing what I was doing. Why the fuck am I just scrolling like an idiot? Why? The fuck? Oh, maybe it's not actually executing the build because because the file hasn't changed. Only the compiler has changed, and so it doesn't know. That's funny. 30639. 30639. Analyze ref. Interesting. Okay. So can we just be like sema is we have like SPIR-V something allowed? Check SPIR-V slice allowed. And this guy wants a block and a source. What else does he want? Pointer type. Oh, this is not how it got merged. Fuck. Hold. Hold. That's fine for now, though. It's fine. We'll just do it like this. Pointer type. Surely. 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 The function changed a little bit in PR review, but I'm just gonna do it like this for now, and then I can fix it later when I actually PR it. I should probably remove that unreachable, right? In here. We probably want our thing to not crash every time it finds the thing we're looking for. Okay, then what? Build. No, not build, because that is using the cast version. Huh. We've accidentally found something else. That's fun. Maybe, I mean, we'll check. 4803. No. Mem. 4803. Yeah, we are not. We're no. This is wrong. This is wrong. We are. This is supposed to check that it is a slice. Ah, I see. We are supposed to. This does the like check to see if. This is assuming that we already know we're a slice. That's my bad. So if pointer type dot like get, there's probably like get type info, pointer info. There's some like pointer info thing somewhere. Here we go. Can we like look for its size is slice? Then we do this thing, maybe? Maybe it's something like that? It'd be cool if you could just get paid to work on Zig. I've learned this about myself. I have taken money to do open source work before, and it immediately made it not fun. I immediately hated it. So like I know for myself that that would actually kill the joy of it for me, and I would not enjoy it anymore, which is kind of funny. Okay, interesting. So now we're not seeing the compiler error at all, which I would think that we should. Unless, hold. What is the point of life if you don't feel dead inside? That's a crazy comment. That's a crazy comment. Do you have to choose what you work on even to get money on exchange? Because if not, it's a job. So, well, for me, like, just the like stress of knowing that I have to accomplish something at all. Like that in and of itself is stressful to me and like makes the thing not fun. You know what I mean? Like for me, I don't know what it is, but like probably ADHD. But like just the pressure of having to do something just like ruins my life. You know what I mean? Like it's so pathetic and like not like makes me like not a functional human in society in a lot of ways, but like just like the idea that there is a thing that I have to do, even if I get to choose what that thing is, just like ruins my emotions. Like it just makes my whole life like miserable in some ways. Like going to work less so, but like having to come up with work and do it, like yes, I don't know how to explain it, but I just know that I can't take money to do open source work. I know I can't because I learned that about myself in the past. So this is still happening. We need more information about this type. First of all, I am assuming that we're trying to cast to this pointer type. Oh, we have this here, right? So this is the operand type, address space, alignment. You know what, actually? When we look at the AIR for this thing, sorry, over here, it's interestingly not a slice. Which is kind of interesting. What the hell is going on there? What the fuck? Does this behave differently if we do it like this? Oopsies. Hold. This is interesting. So now this thing is showing up as a bit cast. There's all sorts of ways that this is... No, this is not true. This can't be it. Slice elem val maybe is okay. Does this thing... hold? Does this thing fail the SPIR-V validator? Hold? Okay. Okay. Very interesting. Very interesting. I don't know what this is telling me. But it looks like there's many ways that we're hitting this case, right? Because now we are definitely still making some invalid stuff. But this like slice lm val now has the entire structure right here. I wonder if there's like a limit to when it will pass it that way. No. Okay. Very interesting. Very interesting. Because remember, this is not what we were seeing in the original atan binary too, by the way. Even though it looks very similar. Huh. Huh. So there's even more cases. Even more cases where we have to ban this. I mean, we could focus on this one as well. Because this is still generating invalid code, right? It is, right? Yeah, it is. Because we still have pointer function F32. Interesting. It really feels like just like any type where we have a pointer, we should be checking its storage scope. Like you can't have pointers to function. It's not limited to slice, which is what we did in our original fix. But like really, slices don't even fucking matter. You know what I mean? You know what I mean? Is this getting called in this other case, by the way? Yeah, there's something odd here. Is there a check for this? Well, it's kind of interesting because I don't know if it's always invalid to take a pointer to this stuff. Can we double check that? Can we double check that? Can we construct a case where it's okay? Like if we do like function, we modify x, right? And he takes like a x as a pointer to an F32 and he returns nothing. And then we say like x equals 5, right? I assume that this is a thing that you could represent correctly. Despite the fact that this is a pointer, it's not a real pointer with an address. You know what I mean? It's just like a reference to a thing. And like that would be okay. Interestingly, that would be okay. Var x is an F32 is equal to 0. And then we're like modify x. Right? Like, is that okay? It might be. Right? If we like look at this thing that came out, we do have modify x, which has a pointer to an F32, and this is completely valid code. Interesting. Check the function name of the AR you're looking at. Oh, did I just fuck that shit up? I might have. No, this is it. Interesting. So it is like a pointer to a function scoped F32 is fine. Okay, interesting. Can we undo this enough so that we get back to the point where we had at least the pointer cast? So this is interesting too, because like what even is the problem then? Because this is totally legal. To some extent. Oh, this is the wrong function. That's what you were saying. Thank you. My bad. Slice lm val. Slice lm val. Ah, so maybe it's the slice lm val. My bad. So maybe it is this slice lm val all the time. Slice lm val. Yeah. Asserts that the layout is already resolved. Okay, so this guy's like validate runtime LM-access, validate runtime values. These are like checking to make sure that these things are runtime available to us. I feel like is it just this? It could be. Could be, right? Because this guy's just like checking inside a slice value, I assume. If this isn't it, then we can maybe get a little, we could do our little unreachable trick again. But let's try this. Boom, 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 boom. Fuck, everything's so hard. Cannot just, that's good. Cannot construct slice. So the slice construction actually happens at the access point, which is interesting. So this means that if I then turn this into the array version of this thing, then this should be fine. There we go. Are you adding SPIR-V specific code to semi directly? I'm adding like checks. I mean, the function I added was called SPIR-V, but like you could rewrite the name, like what we called it in here, check SPIR-V slice allowed, which is like if we're on SPIR-V, check, like make sure that this follows the rules, right? But you could call this like, you could just call this check slice allowed, right? And then you would have in sema, you could have something that's like, instead of this checking if it's SPIR-V, you could have like if, target CPU arch supports like slicing or something, right? Like we're using SPIR-V as like a proxy to that here, but like effectively it's the same thing. Effectively, at the very least, the addition of this function was allowed by the owners of the repository before. They didn't say that it was like out of place, so I'm like, okay, because I think that like knowing some things about your target, like the how do I say this? The front end like knows the target, and he knows that some things should be allowed on some targets and not on others, and he's like the place who does like semantic analysis. It seems like reasonable to me, but I'm like pretty out of my, this is like, I don't know, right? Like I'm not the guy to ask. I'm just typing what makes sense to me, and then if they say that that's good to go, I'm like, hell yeah, we guessed good. You know what I mean? You know what I mean? Don't, I should put like the disclaimer here that like I don't know what the fuck I'm doing, right? Like disclaimer, do not trust anything I do here as correct, smile. Who the fuck knows? Okay. So now with that change in, when we call atan2, it should get fucking pissed off, right? It should go like, yo, dog, what the fuck? You can't do that. So float from int val. Let's just like, just do this. It doesn't really matter. As long as it hits the code path, I believe. Does atan2 need to say like as f32 or something for this to work? Perfect. So once again, he's going like, yo, dog, this thing can't be a slice. So then the question becomes, though, like, what is the fix here, right? So we know, was it atan2 zig? Or atan, maybe? Like, we know that this thing can be turned into an array, right? But I think the semantics of it are different. Right? If we in here write, change this to say this. This says on the stack, put a bunch of floating point 32s, which I don't know if that will like compile into the same fuck, how do I say this? Like, this code probably creates a pointer to a thing in constant memory in the executable normally, right? Where, like, this might copy it onto the stack, which is not ideal. I guess technically, if you did this, now these things are guaranteed to be in, like, global memory, and then it's okay to kind of treat it this way. I think that this is okay. I think this has, like, the same semantics here. Couldn't we just use the SPIR-V built-in function? I don't know that that exists. Like, how do I say this? I'm stupid. Does SPIR-V have built-in functions? Like, I don't know if that exists. I know that, like, GLSL has those things. Like, atan2, right? SPIR-V, atan2. I don't know if that's, like, a thing that is provided to us. You know what I mean? Like, you would have to, like, link in extended instructions, maybe? Atan. Aha, here we go. So there is, like, a... Yeah, okay, wait, but this is, like, GLSL specific. So this is interesting. So we could theoretically be like, if we're on OpenGL, then maybe, is there, like, a stud SPIR-V? Like, does this guy have... I don't really know, like, the linking model. You know what I mean? Like, there's a world where you're right? Like if we have this thing as, like, the driver has an implementation internally already, like, we should use it. That's better, right? But I don't know how that stuff is resolved. Interesting. So, like, I guess we have a sample though, right? In the SPIR-V zig here, we have this, like, global invocation ID thing that is, like, an OpenGL provided value. So the question is how the fuck do they get this? You know what I mean? Like, where is this coming from? Global invocation ID. Is this, like, in the link phase? Or is this like a... Oh, here we go. Codegen SPIR-V spec. So this thing, it has, like, an assigned number to him. And so maybe, like, this atan2 function gets, like, a specified number as well. atan2 is under extended instructions, by the way, not functions. Yes, sorry, not clear. Oh, so you're saying, like, maybe I can just emit, like, an atan2, which I guess means that, like, yeah, you might be able to do something like atan2. Like, can we just write like this and, like, do our inline assembly syntax? That's, like, maybe, right? Like, where was our extended assembly syntax? It was, our example was in mem. Do not optimize away. Here's our example. Right, so, like, maybe we can do something where we call, like, atan2, and he just takes in a y and an x, right? So we have y and x, which I guess we should call y and x here. And so this is going to be... fuck, what was the syntax? Zig lang ref. ASM. Or what was it called? It was assembly. It was the title. Do we have an example of them using these things in here? No, but there's some way. It's like, you know, it's like something like this. Maybe like this. Is that how this thing worked? And then this needs to have, like, ret. which I don't know how this is going to be output here. But this is also like a register. And we want this to go into somewhere. I guess like this. According to this syntax, right? Kind of looks that way. We don't use the name in here. It's just a thing that's going to be output by atan2, I would think. And then what is the, like, constraint here? I don't fucking know. None? Like, I don't fucking know. Where were they talking about the constraints documentation again? Here, GCC, output operands, constraints like this, simple constraints. Feels very R. We can look at the codegen as well. Right, so iterate outputs. Yeah, so they want a returned output, which is good. And they don't really care about the constraints at all, right? They're not even looking at them, so who gives a fuck? Who gives a fuck? Right, so that seems kind of right to me. Seems kind of right to me. And then, I don't know, like, I don't know if the syntax is like this or what. But do we have, like, an example? GCC inline ASM. Or maybe, surely there's, like, some reference somewhere where they have, like, ASM. What was it called? Like, there's gotta be, right? There's just gotta be an example somewhere where they're doing... Here we go. That's how they name it. Like this. Percent, then square brackets, then the thing. Which is what we did. Nice. I guess we do need to return the thing. That's a good point. I'm confused by SPIR-V 32 OpenGL. Does that mean the SPIR-V spec has like an OpenGL compatible API? It does seem like that, right? It does seem like that. Failed to assemble inline assembly. Safe allocator leaked. But did it build? Yeah, so somewhere they're like leaking in the implementation of this thing. SPIR-V codegen. I guess it's SPIR-V codegen. So we're leaking from, where was it complaining about? So I learned the term, gosh, is this something I can say on a programming stream? I learned about the term cum gutters at some point, where, you know, somebody who's got like hot CGs are like, it's like like the indent at like your waistband underneath your abs. And so now every time I see CGs in here, I'm like, this dude, my compiler's got some sick CGs, man. And it's like, who, like, why, shut the fuck up. Shut the fuck up. I'm very familiar with the subject, yeah. So just every time I'm like, dude, these CGs, I got some fucking hot CGs in here. Like, shut up. Okay. So I think the only problem here is that we're leaking memory. I think. So this looks like it is all in... well, failed... Let's look for the failed to assemble inline SPIR-V. And this is coming from assemble fail, so maybe the leak is just as a result of this. It's hard to say. It's hard to say. It might have to parse the instruction and turn it into an opcode. And that opcode may not be known, right? That seems possible. right? Like this extension, he has opcodes here. So these need to be called through op_ext_inst. Oh, okay, so we shouldn't be doing whatever the fuck we're doing is wrong. This is op_ext_inst 25, I believe is what it said for atan2. Okay, let's try that. I think the like leaks were like a result of something else. Fail to assemble. Does he know about this? Like, I don't know how all of this is supposed to resolve. You know what I mean? op_ext_inst. Okay. So you're supposed to use op_ext_inst import is what he wants in here? op_ext_inst import. SPIR-V. Maybe that's the play. op_ext_inst import. Aha! Okay, so here is an example of them pulling in the GLSL pieces, which we should double check. Do we have that in here anywhere? Does not look like it. op_ext_inst import. Okay, so no. Okay. So we might need to somehow get that in there. And then how do they use this like %1? Is that used anywhere? Like, no? Like, shouldn't they have to call this thing somehow? Maybe it's just like through like an OP call or something. I don't know how like you call functions in this language. You know what I mean? Like, they have OP function here, which gets %4. You missed it, %44. Aha, opx_inst where they call %7. What is %7 here? This is a type. I see. So they like get the output type with the value of the number, but then they have the name as well, which is interesting. Oh, I see. They're saying from this namespace, the OpenGL namespace, call the square root function with this argument. So we first have to load the namespace, then call with the namespace. And so I guess like you kind of like I can't just put that assembly directly inline myself. I don't think, right? It's almost like how are globals initialized in here, right? Like what does our output look like? Right, there's like all of this stuff here, like completely outside of function space, right? I assume that like if we look like OP string, that's okay, maybe OP entry point. Cannot export entry points assembly, right? Like that's kind of like what's happening in here is like you can't fucking use that thing, which makes sense, right? Maybe this is admitted by the linker, which isn't very helpful. What about like when we do like OP type int? Right? This is like maybe these are valid within these, which is not helpful. Oh, we're in assembler. Oops. I want to know like where they yeah, see they have like a globals section where they're putting this stuff, right? So like we would also want to put our like load of the OpenGL functions into that global space. You know what I mean? So okay, let's step back for a second. I believe that you are correct in that we should use the OpenGL implementation of atan2. Full agree, right? However, we can easily fix this bug with less code by doing the other fix that I was going to do. Because I think that implementing this will be a little bit of work, right? We're going to have to, in codegen, maybe if we're on like OpenGL platform, we like import the GLSL namespace, and then from there we like export a bunch of, like, you would have to like export the ID for that thing somehow in a way that's like accessible from other inline assembly blocks, and then inline assembly blocks would have to then be able to reference that thing and pull, you know what I mean? There's like some like global variable you have to pass around. And I think that that's, while that is better, I do not want to do that right now. I think that the fix, we can get a fix for this thing simpler by just modifying atan thing to do what I was going to say, which was just that we put all of these arrays in a global space, which is annoying, but I believe this will fix the bug. We just kind of whoop. And then this is all standard library changes, so we don't have to recompile, I don't think. Oops. And then we'll go back to using, we'll just kind of fuck this shit. Okay. I don't understand why I have zig libdir specified here. Oh, this is going to the wrong spot, that's why. What is it, lib stood? Or something? Work zig lib. Oh, maybe it's just like this. Hype, and then SPIR-V val of this thing. Good, promising. Can we go back to like our original function to do arcs? Oh, oops. Hold. Is it different on the zig build command? I'm not sure. Unsure. What am I looking for? Libdir. No, we're good. Zig libdir is home streamer work zig lib. Okay, well, fuck me, I guess. Hello? Zig libdir. Oh, was I using the wrong version of zig? Maybe the new zig has a different name for it? It is, that's crazy. Okay, it's zig lib equals. Unlucky. Zig lib argument of special must be first. Fuck you. Sorry, that was rude. That was rude. I take it back. I didn't mean it. I could never be mad at you, compiler. I could never. I think we left some debug prints in there. Thoughts? Do you think maybe we accidentally left some in there? Maybe just a few? Maybe just a couple? Semi, I think is where we had them. Debug, print, pointer cast time, compat pointers. Found a pointer cast. That one looks like one of mine. There we go. I think that this is actually having like an impactful like change on compile times, which is funny. I think that is like legitimately slowing down the compilation because like it's just in the middle of all of this like semantic analysis has to like flush standard out over and over again. That was pretty fucking funny. Dude, something's definitely bugged that every time I compile it has to do first time setup, right? That's gotta be a bug. It's gotta be. Alright, give him a second. He's gotta think, and then he's gotta think again, and then our other guy's gotta think. So much thinking. Think, think, think. Sir? Sir? He is still working. You can do it. There we go. There we go. Now we can compile the compiler. I love it when the compiler thinks of me. It's so true, though. Dude, can you imagine if the compiler didn't think for you? God, that would suck. That would suck. Okay, there we go. Oh, we have to compile maker again. Can I turn this shit off? Are you modifying sublib instead and maker depends on it? Probably. Probably. Sir, I'm gonna need you to finish compiling. Yes, that's exactly how I feel. Please enter the byte offset of field X. Yeah. It's like, thank God that the compiler, thank God for the linker too. Can I say it? The linker, he's doing a lot of heavy lifting. Can you imagine if the compiler put all these offsets, then you had to link yourself? Oh my God, dude, that would suck. I think that would arguably suck more than compiling. Arguably. I'd rather handwrite assembly with a linker than try to hand link compiler output. By like a long shot, actually. Like, holy. Imagine being employed as a linker. Yeah, that's a job we can lose, I'll say it. Holy shit, we compile. Does it work? Did we... Huh. That doesn't look right. Yeah, arc crosses should be getting appended correctly now. Yeah, all of these things, I would think that at this point, we should, when we compile this thing, we should see the full outline of our Blender icon. But we're missing all of the arcs still, even though I think that they should be implemented. That's interesting. That is interesting. I wonder what the problem there is. Are we forgetting to give them to the guy? We might be forgetting to give them to him. We might be forgetting to hand them to the GPU. Where the fuck would that be? Type 3? I mean, he definitely thinks that they're there. Maybe this is just bugged for some other reason. Is there an easy way to prove that atan2 works? Is there an easy way to do that? 0, 1, 2, 3, 4, 5, 6. We just double check this as well. 0, 1, 2, 3, 4, 5, 6. I mean, that seems right. Seems fucking right to me. I wish I could, like, print something in here, too. We know that this function works on CPU, because the thing is rendering correctly. Just add Claude link for you, easy. Yes, so true, so true. Yeah, so this function is correct on CPU, which is good. So which means that its GPU side is doing something unexpected. I just can't figure out what. Fuck. Sorry, I'm just thinking. Because it would be the dream end to this stream is that we see the whole thing. That's just the dream. That's just the dream. I mean, there's a possibility that it's calculating something wrong. Like, do we see points anywhere, like, zoomed really far out? No. Do we see anything, like, in here? Like, is it, like, scale is just kind of fucked up somehow? No. Out length 61. Am I forgetting to... So when we walk our contour, we find some things. We say, hey, GPU, here is your arguments for this type, And could you then put your things in this position? And then he does that. Can we look at the output indexes for arc crosses? Maybe? Like if our output format for this thing contains what type it was for, then we can kind of filter for if he found any of this type. I think that's fair. Let's do that. Let's do that. Let's do that. Okay, so that should still work. That should all be the same. And then we should be able to like extract this data and print it. And we should see if we're going through the arc path at all. Okay, read back, he needs to have that same type. So this is going to be, what was it called? It was like in type. And let's then, if val valid, if val in type is not equal to 3 for arc, 0, 1, 2, 3, yeah. And let's just see if we see anything in there. Okay. He does seem to be finding cross points. Maybe it's working and I just thought it wasn't. Let's disable. We just won't give him anything that aren't arcs. Maybe I'm confused. Hold. Oh, okay. Maybe this is working. And we're only just showing the output, the outside contour ID. And he's only showing X positions. It's so weird. I mean, I feel like we're missing some stuff though. Like, I feel like we're definitely missing the bottom of the guy, but maybe. Yeah. Maybe this is getting cut off at the bottom of this. That's possible. Yeah, it's possible that like something's getting cut off at the bottom here that shouldn't be. But we definitely are seeing like some points from the arc. Sorry, this is supposed to be. We're definitely seeing something. We're seeing something, okay? We'll call that a win. Does OpenGL not have shader printf? I don't know what that means. I didn't consider that until right now. I didn't even consider that was a possibility until just now. Okay, cool. I think that is a successful atan2 fix, right? Like, we're definitely, I mean, it's definitely not, like, perfect, right? We see some, like, instability here on, like, corners of probably some of the contours as they, like, adjust. I think that the thing is getting cut off at the bottom because of this, like, aspect ratio. We can actually probably check that. Image height. Where's our, like, 270? Here, can we just, this is 200. Maybe not. I don't know. There's, I believe this is correct. Because again, we did see some component of the arc shown here. I think this is somewhat okay proof of an atan2 fix. There's definitely more to do. So what do we do, first of all? We fixed the compiler errors for detecting when we try to do runtime slicing of something based off of inline data. Like in the, like when we have code that looks like, when we have code that looks like const slice is equal to this, right? This was not correctly compiler erroring, so we fixed that. Then that compiler error triggered in the atan2 function, and then we fixed it to say to use like array syntax instead. Which, I mean, ideally, you would know if your slice was a pointer to like a compile time array, and you could like handle that differently. There's a world where there's a better fix in there, but at least we understand the problem. So I call that a win for today. It's very likely that I don't PR it in its current form, because I think that there's like multiple better fixes for this problem, right? One of those is the just use the OpenGL atan2 functions. But the second one is that I'm pretty, there's got to be some way to fucking notice that this case, right? There has to be. There has to be some way to notice this case. And so maybe finding a way to fix that is better. So we'll see. But I think it was a success for the day. We definitely did something interesting. So cool. Thanks for watching. If you like what we saw, we stream, I don't know, every other day-ish around 12:30 Pacific time. We stream for, 2 hours, it seems like, is the average now. Sometimes we stream more. When we stream stuff that does not fit nicely into a YouTube title and thumbnail, then that goes into Patreon or into YouTube members, or into Twitch VODs. And if you pay in those places, then you are supporting the stream and helping it extend the lifetime of this project. And also getting something in return. Obviously, no pressure. Ideally, if you don't watch any of that stuff, you don't miss anything too interesting. So I try to structure it that way at least. I think that's it. YouTube, peace. Twitch, let's find someone to raid.